Hi everybody. In this lesson we want to look at how we can solve some rational formulas for a particular variable. So let's get started with this example. It asks us to solve 1 over big R equal to 1 over little r1 plus 1 over little r2 for big R. So I'm trying to get this big R all by himself on one side. Now what I can't do is I can't just flip these over and expect that big R to equal little r1 plus little r2. So if you ever have an equation with fractions, the standard procedure for solving that is to go ahead and multiply both sides by the least common denominator. So in this case, the least common denominator is going to have the big R and little r1 and little r2 in it. So let's multiply both sides by that least common denominator. Okay, so let's on this side, the big R is going to cancel, and I'll just get little r1 times little r2. And then over on this side, I will need to distribute that to each of the terms. And so when I distribute it to the first term, the little r1 is going to cancel, and I'll be left with the big R times the little r2. And when I distribute it to the second term, the little r2 will cancel. I'll be left with big R times little r1. Okay? Now again, I'm trying to get R all by himself on one side. And here, now, since I multiplied, I actually have two R's. Well, the way we take care of that is I just go ahead and factor that out. I'm really combining like terms. You could think of it as having little r2 big R's plus little r1 big R's. And so if you combine those together, you would get little r2 plus little r1 big R's. Okay, that's the same thing as just factoring out the R. Now I've got R right there, and I can go ahead and just divide both sides by its coefficient by the R2 plus R1. So we'll divide both sides. And so then this whole thing will cancel, and I'll be left with my big R. Let me write it over here on the left. Is going to equal R1 times R2, and I'll go ahead and just write these in order as well, since that doesn't matter. R1 plus R2. Okay, so that would be my solution as I solve that for big R. So let's go ahead and do another example over here of that. In this case, if I'm solving for t, I've got a t here and a t here. Well, again, if you ever have an equation with fractions, the very first step is to get rid of the fraction. So in this case, I'm going to think of this k as k over 1, and then this is really just a proportion. K is to 1 as RT is to R minus t. So I could just cross multiply, and that would be the same thing as multiplying both sides by just R minus t. Okay, so either way that you want to think about that, you get the same thing. All right, so in this case, the R minus t's would cancel there, and I'd get k times R minus t over on this side is equal to just RT here. And notice that's the same thing as if I cross multiplied. 1 times RT is right here, and then the k times the R minus t is right there. All right, so now I at least got rid of the fractions, but I still have two t's. And in order to combine those, I'm going to have to first distribute this k to each of those terms. So I'm going to get kr minus kt is equal to rt. All right, so I'm aiming to get these together. So let's go ahead and take the negative kt over on this other side. So I get kr is equal to RT plus KT. Now they're on the same side. And now I can do like I did over here. All right, I have RTs, and I have going to add to that KTs. So that's going to give me R plus KTs, the same thing as if you'd have just factored out that T. All right, so let's go ahead and divide now by the coefficient by the R plus K. And so I'm going to end up with my t value. Again, I'll write that over here on the left because these are going to cancel, the r plus k's. And I'll have, let's write it in alphabetical order, I guess, kr over k plus r. Okay? All right, one last example here, a little more complicated. I'm trying to get T2 all by itself on one side. So again, I'm going to start off. The first step is to always just go ahead and get rid of the fractions. So just like in the previous example, I'll think of this as s over 1. And let's just go ahead and cross multiply. I'm going to get sm times t1 minus t2 is equal to h times 1. All right. Now I want to get that t2 all by himself, so let's go ahead and distribute the sm to each of these. So we can unwrap the t2, get it by itself with its own term. So I got smt1 minus smt2 is equal to h. All right. So I'm going to get this t2 term all by himself. I always like to have a positive term, so I'm going to go ahead and bring this over on this side so it makes a positive smt2. And I'll go ahead and subtract h from both sides. All right, so it's kind of like these just swap places. All right, so now that I've got the t2 term all by himself, I'm almost done. All I have to do is divide by the coefficient, in this case sm. And I will have my answer because the SMs will cancel, and I will have that my T2 is equal to the SMT1 minus H all over the SM. Okay.